I have some time, so I'm going to record a video. I'm making up some problems where we're solving the missing parts of a right triangle. I feel some of you are still struggling with this concept. And there's really two cases. So one case is where we're going to need to use trig to find one of the sides. Okay, we must use the given information. We'll set up a trig ratio, and then once we do that, we'll know the sides. Then we can use the Pythagorean theorem. We can use complementary angles to find all the other parts. Okay. The other case is where I give you enough information to find the sides without trig, but then we need to use trig to find the angles, or at least one of the angles. Then you can use the idea of complementary angles to find the other. Okay. So let's just make up some couple just to review this, so that when you see this on the exam, you know exactly how you're going to set up the problem. So I'm going to make a right triangle. Okay, I didn't even think of these numbers, so I have no idea what we're going to do, but I'm going to label it A, B, C. And so for this first scenario, we'll use trig to find a side. Okay, that means I have to give you one of the angles. So we already know that it's 90, so I have to give you another angle. So this is right triangle trig. I will give you either angle A or B. Let's go with angle B, and let's make up 27. I'll make a 27 degrees. And then let's say I give you side A is 5. Okay, we have to find B, we have to find C, and then angle A, which is going to be real easy. So on a test, I would ask angle A. That's your given. That should be so easy to be able to find. Okay, then I would ask for side B and side C. Okay, so this is where to find A, this is all you know. You take 90 degrees. Okay, it's just a complement. Now some people add the 90, and then you're really finding the supplement, because all three angles add up to 180. But I already know it's a right triangle, so if I just simply subtract, I know angle A has to be 63 degrees. Okay, so big idea is that was real easy for you to do. Okay, so now I must use trig to find either side B or side C. Okay, so I'm going to use the angle that was given. I originally gave you angle B. So if I draw my attention to angle B, knowing that it's 27 degrees, my opposite side is B, my adjacent side is the 5. Okay, so I would use that, and I know you have to know your trig ratios, SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And in this case, I'm going to use the tangent. So I would want to see this. I would want to see the work, the trig ratio that you're using, the tan of a 26-degree angle. Okay, you can't mix up your angles and stuff, so this is going to be the smaller side. So I expect an answer less than 5. Okay, so if I have opposite 63, 5 inches, 5 units, whatever the units are, my B has to be less than this. So it should make sense that when we get an answer, when we solve for B, it's going to be less than 5. So opposite side is unknown, but my adjacent side is a 5. Well, that's super easy to solve. Okay, so to solve this, I just type in the tan of my 27, and make sure you're in degree mode. Okay, so hit mode just to double check, hey, I'm in degree mode. And then hit enter. Let the calculator tell you the relationship between the opposite side and the adjacent, which is about half. Okay, so I know my answer is going to be about 2.5. But to solve for B, all I need to do is then multiply by 5. So I basically multiply both sides by 5. I'll hit times 5, and I'm going to see 2.5, and I'll say 5. Okay. Well, now I don't need trig. I could use trig. I could use, say, I would do cosine. I could do cosine and have my adjacent over my unknown hypotenuse, and we can solve for C. It would be a little bit harder to solve, but we have the Pythagorean theorem. So when you're solving these, you only need trig one time. And then let's quickly use the Pythagorean theorem. So this time, I have both legs, so I'm just going to take 5 squared plus what I just found, 2.55 squared. Don't forget to take the square root. There's no way C could be 31.5 units. I take the square root, and I'm going to see that my C is about 5.61. We'll round to the hundredths. Okay? So that example is an example where we used trig to find a side. Let's make up one more, and then we'll do the other scenario where we're using trig to find angles. Okay, so let's make up another one. Here's my right triangle. Now remember, if I don't give you a right triangle, I just tell you, side A is 10 and angle B is 27 degrees. You have to make one and then fill out that information. But I have one here. I'm just going to make up A, B, C. So there's my hypotenuse. Here's where little b would be, and opposite angle A would be side A. Okay? So once again, I'll give you an angle. Let's say A is 35.7. Okay, so I'm telling you, angle A is 35.7. And then let's say I tell you hypotenuse this time. Let's give you a hypotenuse. Let's do 28.9, okay, units. Well, actually, we'll even use feet this time. Okay, so that's what I'm given. I would have on a test, I would need to know angle B, I would need to know side A, and I would need to know side B. Okay, so no trig necessary. 90 minus 35.7. I can at least give you a point for telling me the missing angle. Okay, so I know B is 54.3 degrees. Okay, so I'm going to use angle A, again, angle that I gave you, and then my opposite side would be side A, the adjacent side would be B, and my hypotenuse, always the longest side of my right triangle, is C. So now, up to you. You would be in trouble if you use tan. Okay, so if I use tan of a 35.7, you can't solve if you don't know the opposite and you don't know the adjacent. And I have two unknowns. I would set up A over B, and I can't solve for that. But we could use the sine. We could use the cosine because I know the hypotenuse. Okay, so I'll just use sine. So to find A, so I'm going to show the work here, the sine of a 35.7 degree angle is defined as my opposite side, which we don't know. We call it A. That's what algebra is all about. A variable taking the place of a number, and 28.9. Okay, calculator can do this so quickly for us. It can easily tell us the ratio, the sine of a 35.7. It's this ratio. It's 0.5835, and all I'm going to then do to solve for A is multiply by 28.9. Okay, so it's about a 16 point, and I'll say 86, and that would be feet. Okay, so now I'm going to use the Pythagorean theorem, and I'm actually going to keep this stored in my calculator, this side. So to find B, I'm going to take, so basically it's C squared minus A squared equals B squared. So that's what I'm basically going to type in my calculator. I know my hypotenuse is a 28.9. I'm going to have to square that, and I'm going to have to subtract my leg, which we just said was 16.86. I'll just write it like that, but I'm going to keep it stored in my calculator to be a little bit more accurate. We're going to subtract that answer squared, okay? And it comes out to 550.8. There's no way that can be the length of B, so we have to take the square root. So square root of that answer, you're going to see that B is 23.47 feet. Okay, so this would be 23.47 feet. Okay, and just a couple little things to keep in mind. I expect B to be the bigger side because this is my bigger angle. Okay, so stuff that you learned in geometry, the relationship between sides and angles, this is going to hold. So it's a way of checking your answers. Okay, so that was two scenarios where we had to use trig to find a side. Well, let's do trig to find a missing angle. Okay, we have to use trig to find an angle. So once again, generic right triangle. We'll make up some numbers. Let's do it so you can see it. A, B, C. Here's C. Here's B. And here's A. So in this case, I have to tell you two of the sides. Okay, I can tell you both legs. I can tell you hypotenuse. Doesn't matter. I'm just going to quickly come up with numbers. Whatever pops in my head. 65 inches. Okay, we'll call A 23 inches. Okay, that's all I need. So then I would expect you to be able to easily tell me B, and then angle A, angle B. Okay, so in this case, we can quickly use the Pythagorean theorem, at least get a point. So we can at least use A squared plus B squared equals C squared to know what the missing side is. So since I know my hypotenuse, I'm going to type that number in first. I'm going to subtract the one side, take the square root of that answer, and we're going to see that B is 60.79 inches. Okay, so 60.79. Okay, now again, using trig, I wouldn't really use this side. I would use A and I would use C when I'm setting up my trig ratio to find the angle. That's just me because I'd rather not use the number that I had to calculate, because what if you made a mistake? Then there goes all the other points. So I'm going to use the 23 and 65. So now you first have to decide what angle you want to find, because it matters. Okay, you know, if you change your perspective, it changes the names of the sides. So we're going to find A first. So if I want to know angle A, I need to know that this is my opposite side of angle A and this is my hypotenuse. So that is simply the sine. So sine of A. If you were using B, you wanted to find B first, then I would have to use the adjacent side and the hypotenuse, which is cosine. Okay, so I'm going to take the sine of A, and that's going to be 23 over 65. We have to know that ratio. For the calculator to tell us this angle, it has to have a complete ratio, okay? At any time we're finding an angle, that's when we hit the blue button. So if I'm finding an angle, and make sure you're in degree mode, and all you have to do, second, and in this case, type in the sine, and then type in your ratio. And it's going to know that angle A is about 20.7, and we'll keep it 2 degrees, okay? And then I can just take 90 minus that answer, and just like that, I'm going to know that this B is 69.28 degrees, okay? So only need trig one time, okay? So let's do one more. Total of 4 examples in this video. Hopefully it's not too bad, too boring for you, but I'm hoping it makes sense, and go back and look at the notes, redo the problems in our notes, go back and look at big ideas so that all this stuff makes sense to your brain and that you're making the connections. Okay, so last thing, we will once again use trig. So A, B, C, we'll use trig to find an angle. Okay, so last time I told you C, so let's go with both legs. So if this is 17.8, and we'll do centimeters. And then let's say this is 30.2 centimeters. we need to know side C, we need to know angle A, we need to know angle B. Okay, so once again, not necessary to do trig to find my hypotenuse, my missing side. So this time I gave you both legs. I'm going to take 17.8 squared, that's your B, and then I'm going to take the 30.2, I'm going to square it, let the calculator tell us this total, then take the square root, because that's what C squared equals. So C would be 35 point, and then we'll say 0.6 in centimeters. And that should make sense. That has to be my longest side, okay? Has to be the longest side. And now, let's find angle A, okay? So we'll use A. Bring your attention to this side, or excuse me, this angle. So this side is my opposite, and this is my adjacent, okay? Again, we could use the hypotenuse, but since we had to round it and we had to calculate it, it's best to use the sides that were given. And when you look over at the trig ratio, SOHCAHTOA, you'll know that we must use tan. So it has to be tan because I know the opposite and I know the adjacent. So I'm going to set it up. I'm going to show this on my paper. The tan of some unknown angle, but I do know the complete ratio is 30.2. So my opposite side's bigger, so this is going to be my bigger angle. And then 17.8. And we can easily ask the calculator, hey, calculator, look up this angle. So second tan, it can quickly go through its little memory bank and find the angle that has this ratio. It is a 59 point, and we'll say 4.8. Okay? And once you do that, get another point then by finding its complement, which would be 30.52. Okay, so that's all I need for you to be able to go into a test understanding right triangle trig. Okay, so hopefully this video helped some of you. This is what, again, go back to 9.1. This is what we were supposed to learn in 9.1. Thanks for watching.